storms ravaged cities around the world.
The New York City subway system shut down.
The city received over 200 millimeters of rainfall, the highest since 2015.
As the climate crisis worsens, extreme weather events are becoming ever more common. And these concrete jungles aren't exactly helping.
Infrastructure is impermeable, so often you get flooding because the water's got nowhere to go.
In fact, the industry that builds this infrastructure is making things worse. 11% of the world's carbon emissions come from construction.
We cannot afford to carry on business as usual.
In 2 years, China poured more concrete than the USA did in the whole of the last century.
So how can humans build without it costing the earth?
We have 3 kids, we have their futures to think about, our futures to think about.
Nureed and Muzamel and their 3 kids live in the Bay Area of San Francisco. They bought their house 3 years ago, but now with a growing family, they need more space.
I'm thinking that in order to give us more space in our bedroom, we just build out 8 feet this way. When we bought the house, we had really grand plans to add 1,000 square feet and make it a huge home. And then we spent some time researching and analyzing and really going through it. There's a lot of good things about living with less. There's less cost for heating and cooling, but then that impact on the environment. We really made a conscious decision. We've now scaled it back to about 100 square feet. So we're headed to the primary bedroom. We don't have a ton of closet space, so really only my things fit in this bedroom, whereas Muzi's things are actually out in the hallway.
The environment has always been close to Muzamel's heart.
We can go out from the back.
Something he made clear to Nureed on their very first date.
I told her she was perfect except for the fact that she didn't recycle. And it was understandable that she didn't recycle, she explained to me, because she lived on a fourth floor walk-up
that had
on the Upper West Side of Manhattan.
That had 16-foot ceilings. So every time I had like one bottle living as a single person, I'd have to go down 4 flights of stairs to take it into the recycling. So he made me invest into a recycling container that he then would take out once a week.
I got the exercise at that point.
The couple's plan to extend their home may now be more modest, but they're just as determined that the work does as little harm to the environment as possible. And there's one very familiar material that really concerns them.
This one factory is now turning out 15,000 concrete slabs, enough for 35 houses, every week.
It seems like concrete's been around forever. It was the Romans who first started using it for everything from aqueducts to the Pantheon. Today, it is the second most used resource on the planet, after water.
The big users of concrete at the moment are countries like China and Southeast Asia. I've seen reports that in 2 years they poured more concrete in China than the USA did in the whole of the last century. And of course that's associated with huge carbon emissions.
At Imperial College, Professor Chris Cheeseman is an expert in all things concrete.
Concrete is an amazing material. If you think about what it does, we take a grey powder, we mix it with some aggregate stones basically and some finer sand type materials, and we mix those with water, and it's flowable. You can pour it, you can make it into a shape. And then, like by magic, it turns into a rock.
The grey powder is cement. It's the all-important glue in concrete. But it's the biggest culprit when it comes to carbon emissions. The 5 billion tonnes of cement produced each year account for 8% of the world's man-made CO2 emissions. Among materials, only coal, oil and gas are a greater source of greenhouse gases. Helsinki, Finland. This unassuming city has an ambitious target of becoming carbon neutral by 2035. And it's already a global leader in climate-related technology innovation. Researchers here have taken up a seemingly impossible challenge to make concrete without its most problematic ingredient, cement.
Business worldwide simply cannot continue at the current rate. We must find new, sustainable means through innovation and technology.
materials technology company Betola has spent 5 years working on an answer. Inspiration for the company's cement-free solution came from the mountains of waste being produced by other industries. Using artificial intelligence, it analyses local industrial waste and generates the right recipes to produce its composite cement alternative.
We take industrial waste, for example from steel production, and we combine it with alkali activating solution. And by this way we can reduce the CO2 emissions of concrete raw materials even up to 80%.
As well as this potentially huge reduction in the scale of emissions, there are other obvious benefits to using waste products or side streams.
By providing the possibility to use the side streams, we are actually giving a new life for this waste instead of landfilling into the environment.
It's an ingenious solution, but even given the extent of industrial waste, questions remain about its scalability.
Although the steel industry is a huge industry, in comparison with concrete production, it's relatively small. There's just not enough waste materials. They're not going to transform construction in the way that we might want to.
Transforming construction might instead mean weaning the industry of its reliance on concrete altogether. In this English county, 25 new houses are nearing completion. It looks like a fairly traditional residential building site, but behind these walls, it's anything but.
Hemp, it's not generally used in construction, and that's got some quite unique properties.
Hemp is another name for a very familiar plant with a colourful history. But unlike cannabis, industrial hemp contains only tiny traces of the chemical that gets people high. It has some other things going for it, though. It grows incredibly fast. Its fibres are also surprisingly strong.
What we're doing here is using the woody core of the plant, which is called shiv, and we're just mixing it with lime to make a rigid insulation material. It's fireproof. It also has fantastic thermal inertia, so when external temperatures fluctuate up and down, the internal temperature of the house stays very constant. It's just generally a good insulator, and it's locking up carbon. This is about 300 square metres, so if you scale that up, this house, if it was built in a conventional way, would be responsible for somewhere between 150 and 200 tonnes of CO2 emissions. We're able to get that to zero, so that's a massive carbon saving at the construction stage, as well as the fact that it will be operationally zero energy going forward as well.
Hemp used in this way can clearly help deliver significant reductions in carbon emissions, but its nickname, hempcrete, might be a little misleading.
It's an interesting material, but you're not going to build major infrastructure out of hempcrete. You might build an extension or even a house out of hempcrete, but it's not going to compete with concrete as we know it, because it just doesn't have the mechanical properties and strength and durability probably as well.
Here, Greencore isn't working with hemp alone though. It's building with wood. And as the search for sustainability grows, so does the revival of interest in the potential of this age-old material. At Cambridge University's School of Architecture, Michael Ramage and his team are taking inspiration from the past to inspire the construction industry to new heights in the future.
Oakwood Tower was a demonstration project and a research project to show that building really tall in wood was possible. So we engineered this 300-meter tower for central London, and we showed that it was possible for it to stand up.
Whilst Oakwood Tower is just a proof of concept, it's based on innovations that have transformed the load-bearing strength of wood.
In the last few decades, a new category of engineered timber has emerged, in particular cross-laminated timber, which are very big engineered materials made of wood that are strong, and they can be used as replacements for steel and concrete in buildings of all sizes.
CLT is constructed in a controlled factory environment by gluing layers of wood at 90 degrees to each other. The layers are then hydraulically pressed together, creating high-strength structural panels. Using computer-controlled joinery machines, any shape of panel can be cut before being transported to site.
Timber building sites tend to be much quieter than other building sites because they go together mostly with battery-powered drills. Construction is much quicker because the timber arrives on site prefabricated like flat pack furniture, and it gets lifted into site by a crane. While high-rises are lots of fun to design and an interesting challenge to engineer, most of the buildings that we need are not high-rises and are ideal for building in cross-laminated timber.
But one thing everyone knows is that wood burns. For many, fears would be fueled by the prospect of wood-built cities going up in flames.
Cross-laminated timber is of course wood, and it will always be a combustible material, but we know how to make fire-safe designs in cross-laminated timber. There are a range of different strategies so that fires don't spread if they do start, and so that the wood in many cases is not exposed to the fire. It's often behind layers of plasterboard. But one of the big challenges with wooden buildings is that the wood is lovely to look at, and architects and clients and engineers want to expose the wood as much as possible. And that is a challenge for the fire safety. So making those two aspirations work together is something that all of us, I think, in this area are working on and hoping to solve.
In 2018, 55% of the world population lived in urban areas, and that is expected to grow to 68% by 2050. They will need homes to live in, offices to work in, and more of the infrastructure people rely on. The construction industry's got its work cut out, and it faces a monumental effort if it's to become truly sustainable. As well as novel use of old materials, from industrial waste to hemp or timber, more new solutions are going to be needed.
Every company out there is pushing the green agenda. I think the pull is really coming from the customers. People want low carbon buildings now. There's a big pull for that. Rather than doing the things we've done in the past, I think designers and architects need to look at how we use materials so that they're used in a way that gets the most performance out of them and we don't waste materials.
It depends when we build it out.
And for people like Muzamil and Nureed, it always comes down to the same thing: money. Being green isn't cheap.
I think for folks like us, where you have limited funds, but understand the morality of making these choices, I think we frequently run up against what's it all worth and justifying spending more money in order to uphold our values.
I'm John Fassman, The Economist U.S. Digital Editor. To keep up with all our climate change coverage, click the link. Thanks for watching, and don't forget to subscribe.